Okay, so hello everyone. Dear authors and invited guests, welcome to Technical Session 3B. My name is Dimahi Patel and I will be the moderator for this session. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the International Conference on Machine and Computing Technologies for Sustainable Development, Manila, Philippines. The conference is being organized in a hybrid mode. The physical event was held yesterday in Manila, and the virtual event is being held through Zoom today and tomorrow, that is 12th and 13th December 2025. In this session, we have 8 presentations. Each presenter will be given 12 minutes for the presentation and 3 minutes for question and answers. On 10 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, you can write it to me in the chat box. I would like to introduce you all to the chair we have for the session. We have with us Dr. Kaushal Shah. Dr. Shah is an assistant professor in the Department of Computer Science and Engineering at Pandit Deen Dayal Energy University, PDEU, with around 11 years of teaching experience. He has published several research articles in reputed venues and has delivered keynote talks. His areas of interest include blockchain technology, information security, data structures, and smart grid. A warm welcome to you, sir. Please share a few words you may have for the presenters today.
Yeah, I think there is some problem with the video. Anyways, I'm audible, right?
Yes, sir.
Yeah. So all the participants, please stick to the timeline. 12 minutes for presentation, 3 minutes question answers, and best wishes to you.
Thank you, sir. We will be starting with the presentations now. First up, I would like to call Yashita Kiledar to present her study on a comprehensive survey on fraud detection in digital finance using deep learning and machine learning. Yashita, are you present? I repeat, is Yashita or any of the co-authors present with us? Okay, we'll be moving on with the next one for the time being. Gomez Torres Esteban. Sir, are you here with us?
Yes, good
Yes, sir.
morning.
Good morning. Please present your study on CAMS plus ML, a model-based approach for context-aware applications powered by artificial intelligence.
Okay, let me show my screen. Okay. Good morning, everyone. On behalf of authors from University of Armed Forces from Ecuador, ESPE, we are very pleased to be on this International Conference on Machine and Computing Technologies for Sustainable Development. I'm going to show my agenda is motivation, problem statement, an overview, architecture, and DSL methodology, end-to-end pipeline, case of study, results, discussion, and conclusion of future work. This paper presents a CAMS DSL, a model-driven development variation of CAMS, because CAMS is a good integration of context-aware model systems. And in this case, we have included artificial intelligence by using machine learning. CAMS plus machine learning integrates machine learning techniques to enhance contextual decision making in application, providing flexible framework for developing intelligent systems. So enables the creation for solution that algorithms and this gives a dynamical adapt to changes to the user environment. This approach is validated through a case of study by using machine learning, Azure machine learning, to train and deploy the predictive models, demonstrating its applicability in real world settings. The results suggest that integrating model-driven development and machine learning improves the accuracy and efficiency of context-aware applications, facilitating their implementation on mobile platforms. Problem statement. First of all, high complexity. Building context-aware apps is difficult because the system must constantly interpret changing user conditions and respond in real time. Manual integration plus machine learning. Integrating machine learning by hand often leads errors, inconsistencies, and extra development overhead. Third, need for information. We need a way to automate context handling and machine learning workflows to reduce effort, improve reliability, and enable predictive behavior. Overview. First of all, we have a DSL. We have adapted a regular DSL, and we introduce CAMS plus machine learning as a domain-specific language that let us model sensors, services, and context. And now with machine learning components is a unified way that simplifies how to develop, describe intelligent behavior. Second, predictive components and reuse entities. Machine learning models are treated as reusable building blocks. They can be linked to conceptual features and embedded automatically into an application logic. Third, automatic training pipelines. Instead of manually training, we use CAMS plus machine learning defines automate workflows, data preparation, model training, validation, and deploy become part of development pipeline. For adaptation, rules plus code generation. The framework generates code that integrates machine learning prediction with context-aware adaptation rules. Architecture. The architecture starts with modeling level DSL. At the base, we have CAMS plus machine learning DSL, where we model aware objects, context features, sensor, and adaptation rules with machine learning models as reusable elements. Here we describe what the app should do under context without writing coding yet. Second layer, transformation level code generation. From these models comes plus machine learning automatically generates mobile code. Training and interface scripts, and optional machine learning operations configuration. This level turns in high-level design into runnable artifacts with minimal effort. Execution level. Machine learning mass context adaptation. Finally, the generated apps runs on device on the cloud using deployed machine learning models to infer context and trigger adaptation rules. So we have in DSL, we have aware objects, adaptation rules, machine learning model definition, and automatically validate you by using Xtext. Okay, we have 6 phases in our methodology. First of all, the context modeling. Second, data acquisition and pre-processing, machine learning training, model development, model deployment, local or cloud. 5, automatic code generation and execution and continuous learning. End-to-end pipeline. We have designed in a special case for smart cities, for example. We can start with DSL model, the second data pipeline plus machine learning training, the deployment in Azure machine learning in order to demonstrate and generate mobile application with Ionic or native. Case of study starts with predicts using contextual features. Second, we define sensors, activity, location, battery, and weather. And we have a model deployed on Azure Machine Learning. Then we have adaptive notification for user well-being. Results. As a result, we have an accuracy on 88.3%, a latency minus 300 milliseconds, and a total 40 reduction in development time. A SUS score of 82.5 over 100%. So a machine learning model is totally reusable across contexts. Discussion. Machine learning plus CAMS or CAMS plus machine learning improves rule-based systems, scalable architecture with cloud and integration, and improves developer productivity. It supports smart city adaptive systems. Conclusion. Machine learning plus model-driven development improves adaptability and intelligence. Automate pipelines reduce complexity and effective for real-world deployments. Future work. Auto machine learning extension for DSL, edge AI, predictive inference, and new domains on augmented reality, IoT, and health systems. Thank you very much. You have my contact over there, and I'm ready to answer any question.
Kaushal sir, any questions for him?
Yeah. Dr. Gomez, am I audible?
Yes, thank you.
Yeah. So any comparative analysis have you done? Any existing schemes with which you have compared your proposed work?
Yes, we have compared um, for this excuse me, for this analysis we have compared because CAMS is a family starting by DSL with the generation of Flutter applications. But automatically using Axeleo and using Xtext, we have developed different types of application. But including machine learning system, we have, first of all, have a reduction of 40% in development time uh, with no use of machine learning, and when we use machine learning we have a 40% of reduction. Also the accuracy and latency have increased in good average.
Okay, thank you. That's it from my side.
Thank you.
Thank you, sir.
Okay, thank you very much for your time.
Yashita Keledar, are you ready to present now?
Yes, I'm ready to present now.
Yes, ma'am. Please present your study.
Just a second. Are you able to see my screen?
Yes, ma'am.
Yeah. So good morning, everyone present here. I'm Ms. Yashita Kiledar from Cummins College of Engineering, Pune, presenting to you a comprehensive study on digital finance using machine learning and deep learning. So I work this under my professor, Varsha Pimprale. So coming towards the motivation behind all of this, as fraud happens very rarely in our data sets, so it's very hard to identify the frauds because of class imbalance is a major problem here. Also, sharing data between banks is risky as banks include a lot of private data which cannot be shared overall. Also, fraudsters keep changing patterns, so it's very difficult for the models to adapt in that way. Also, explainable models builds trust in the banks on in how did the results are incurred. So the main thing was to find out which algorithm worked the best to find the frauds. So, coming towards the background, the traditional models like random forest, logistic regression are robust, but they are limited for complex transaction patterns. Also, deep learning models like LSTM, GRU work better for time based as they have gates that can help us to identify the long sequence of transactions. Also, ensemble and hybrid models like boosting algorithms outperform very well in compared to accuracy. Also, pre-processing steps like smart analysis, as we have a lot of class imbalance, helps here. So coming towards the comparative analysis, so my main aim was that I studied on the recent papers that had these algorithms used, which I was interested in. In the recent years from 2022 to 2025, they use financial data sets in which algorithms were used to find out how fraud data sets are accurately captured with help of certain algorithms. So the algorithms of my interest were like federated LSTM, XGB, all boosting algorithms like XGB boost, Light GBM, cat boost, CNN, LSTM, and GRU with respect to deep learning. In this comparative analysis of findings, the mainly four algorithms that caught my eye was LSTM, that is long short term memory, which works in a way that it learns patterns over time, remembering the long sequences with the help of the gates like memory cell, forget gate, input gate, and output gate. So in the papers, it showed high accuracy and high recall. So federated learning was also into picture with LSTM, which made the banks help preserve their privacy. As in federated learning, we can use the model in your own local banks, and then the weights updates are shared to the central server, in which the banks can preserve their own data. So this also helped to give good privacy, also a good accuracy. So coming towards the strengths of LSTM, were like it works best for the time series data, and also it catches the hidden fraud patterns. The only weakness here was it a heavy model, and it trains it very slowly. Coming to a CNN, it basically learns spatial and local patterns, and it is usually used in image data. But as it obviously doesn't work with transaction and tabular data, so CNN was not of a good practice when it comes to detecting frauds in financial transactions, because here we usually have a tabular data. It is fast, it is simple, but not used here. So coming towards the GRU, which is a lighter version of LSTM, a gated recurrent unit, it also performed very nicely when it came to financial data, but it was good when it came to shorter sequences. Also, it is lightweight than LSTM as it has only two gates. So it is not as stronger as LSTM for long-term patterns, but it can work very well with short-term patterns. So coming towards the boosting algorithms like XGB boost, Light GBM, and cat boost, these perform very nicely, and these were the top performers in most of the data sets, as it gave a higher recall and good F1 score. Usually when these boosting algorithms are used in ensemble stack, it gives a higher accuracy rather than using one single algorithm at a time. So the challenges that were incurred in these surveys and these studies was the major problem like class imbalance, as frauds are very rare in a particular data set. So smart analysis were used wherein the fake and synthetic data were created so as to balance out the class. Also, privacy concerns and regulation is a main challenge when it comes to handling financial data, as you cannot be sharing this data everywhere. So federated learning helps here. Also, like fraudsters constantly change the tactics, so a model should be able to adapt. So while going back, if you see like if there is a sudden big amount that is being shared, so it can be a fraud. Also, if there are a lot of transactions happening at a particular time, so this can be a fraud. So but fraudsters are so smart that the patterns can easily change, so a model should also understand. So this can be one of the biggest challenges here. Also, complex model can lack transparency, as it is difficult to understand how this result was incurred. So like explainable tools also come in picture here. So the future scope can be like to help banks preserve their privacy, federated learning can also help, and explainable tools can also help to identify and build trust, like how you get the result. And also real time and adaptive systems can help spot new fraud tricks, which can reduce the losses of the banks, and also it can help the information safe of the customers. So the overall conclusion into finding which algorithm works the best was like boosting models obviously work best overall, but also LSTM wins whenever the fraud patterns depend on time or transaction history. Also, as compared to LSTM, GRU is a lighter version, but LSTM works better for long-term sequences. And CNN is always the weakest in such data because it doesn't work well with tabular data. So these were the references that I used and incurred a lot of information from it, and did help me a lot of in my survey. So thank you. Here I come towards the end of my presentation.
Sir, any questions?
Yes, Yashita, am I audible?
Yes, sir.
So is there any implementation that you have done, or is it just a review, a survey?
Okay, this is just a survey, but I'm working on the implementation right now with 3 data sets. So it's still going on.
Okay. Uh, how exactly, I mean, do you define fraud? What is fraud according to you?
Okay, so coming towards the data sets, it's like if the transactions are becoming very unobvious, or it is being sent, the money is being sent to very anomalous person, or maybe at a particular time there are a lot of transactions happening. So this can be a fraud.
So how to identify some person as anomalous?
Maybe the bank account number can be very different from the previous ones, like the transaction can be way different from what previously the person had done, maybe like that.
Okay. Just show me your title again. What was the title of your paper?
uh, it is a comprehensive survey on digital finance using machine learning and deep learning.
Okay, so it's not about fraud detection, right? So, I mean,
uh,
about fraud detection. So that is where there seems to be some confusion. Anyways,
okay, sir.
I
Okay.
mean, you can take these suggestions and, you know,
Yes, sir.
go ahead. Okay, let's go to the next presenter.
Thank you, sir. Thank you,
Yeah.
ma'am.
Thank you. Next up, I would like to call Seshu Kumar Chegu. Seshu sir, are you here with us? I repeat, is Seshu Kumar Chegu or any of the co-authors present with us? Moving on to the next one, MD Ator Rahman. MD Ator Rahman, sir, are you here with us? Or any of the co-authors? Basam Abu Trab. Basam, sir, are you here with us? Manjita Kale. Manjita, ma'am?
Yes, I am here, dear Mahi.
Yes, ma'am. Please present your study on optimization of deep learning experiments using Taguchi method applied to facial expression recognition task.
Sure. Okay, is my screen visible now? Presentation?
Yes, ma'am.
Okay. So good afternoon, everyone. My topic for presentation today is optimization of deep learning experiments using Taguchi method applied to facial expression recognition task. So there are 3 types of the work that I have carried out for this conference paper. One is the facial expression recognition system design, which is abbreviated as FER system. I have used a deep learning approach to carry out the facial expression recognition, and then that DL experiment is optimized using the Taguchi method. So the contents of the presentation are as follows. Firstly, the introduction, aim, objective, key contributions, related work, data set which is created for this work specifically, deep learning model to which this optimization technique using Taguchi method is applied, then the obtained result is validated, and finally the references. Coming to facial expression recognition, there are n number of applications where FER systems are used, like in neurosciences or effective computing, education and training, human-computer interaction, market surveys, etc. However, one of the most unexplored application of facial expression recognition is in performing arts, and I have used this application especially for the Indian histrionics, that is to say, Indian performing arts, including dramatics and dance forms. There are various approaches with which FER systems are designed, and as we know, the deep learning approaches are taking over all the other approaches in every other system. I have also applied deep learning approach for facial expression recognition system, but the DL models are time and memory complex because there are n number of parameters, and hence it is important to optimize the deep experiments for the number of rather experiments which will make the DL model time and memory light. Taguchi method is a process optimization technique which was derived in 1989 for the manufacturing process optimization. However, nowadays it is being applied to deep learning approaches as well, and so I have tried my hand on Taguchi method for optimizing the DL experiment. Now, to give you the introduction about the application for FER system, there are 6 basic expressions which are used commonly in the literature, and most of the literature on the facial expression recognition analysis works on these 6 basic expressions only, namely happy, sad, surprised, angry, disgusted, and fearful. However, in Indian histrionics or Indian performing arts, we refer to a literature called as Natya Shastra, and there are 9 specific expressions which are known as Navarasas that are mentioned, and specific guidelines are given in Natya Shastra how to exhibit those emotions. And so, as we are not only working on basic expressions, 3 more expressions are added to the 6 basic expressions, and the way in which the expressions are exhibited are also completely different from what we do in real life. And that is why this calls for an independent analysis of the FER system used for Indian histrionics specifically. The aim of this work is to apply deep learning approach to FER system and finally to optimize the experiment using Taguchi method. The objectives were to use the extensive data set because of the 3 additional expressions as well as the way in which the expressions are exhibited. Then to deploy a deep learning model for calculating the accuracy and loss values for the facial expression recognition task, and the classification should be done in 9 classes. And finally, the optimization part comes in, where in the optimization part, Taguchi method is applied to find the combination of hyperparameters that will yield the best accuracy and loss result. These are a few key contributions. Obviously, the testing the application specific data set for deep learning model and optimizing it. There are a few steps which are mentioned on this slide, which we will be discussing in the upcoming slides. Okay, so now deep learning methods are used in FER systems for data fusion or face cropping rotation, as I have found in the related work. Expression detection also, intensity identification, finding the key points on the face, and then detecting sentiments or emotions. So for all of these, deep learning approaches have proven to be best approaches. Okay, and after that, we have a Taguchi method, which was introduced in 1989, as I have mentioned, for the manufacturing processes. But now they are being deployed in DL models as well, as you can find on this slide. I have mentioned the references as well. Now, coming to data set, standard data sets again include 6 basic expressions. So we needed a different data set which included all the 9 expressions used in Indian performing arts, and this in this specific way they are exhibited. So application specific data set is used for the same, and these are some details of the data set. These are the 9 expressions which are shown with the help of pictures as well. Those 9 expressions are included for facial expression analysis. Total number of images in the dataset are 1445. Number of subjects are 10, and number of expressions are 9 specific plus neutral. All of these facial images are retrieved from the Indian performers, classical dancers especially, and who have been learning and performing from between 5 to 15 years. Image resolution is 6000 to 4000, and the images are color images with makeup only around the eyes and lips, and without makeup images are also included in that. The images are labeled in the specific manner, including subject identity, status of makeup, expression, image number. As we can see in the first picture, it is labeled as S1 anyone, indicates that subject 1 without makeup, neutral expression, first image. If you go for third picture, SM1 anyone, again subject 1, however the image is with makeup, neutral image, and first number. All the image labels are also mentioned on the slide. So every image, depending on the expression, they are labeled accordingly by the experts. Okay, along with the application specific data set, a standard data set which is known as JEF, Japanese Female Facial Expressions, is also used for the testing. And later on for the testing, both the data sets are combined and the results are also obtained. Deploying the deep learning model, we had only 210 images from JEF database and around 1400 images from the application specific dataset. So the deep learning model that was needed is not very heavy, and that's why we went for AlexNet based database, deep learning model, including 5 convolution layers and 3 max pool layers. Okay. There are certain hyperparameters which are set as mentioned on the slide. The learning rate is 0.0001, batch size is 28, epochs are 50, validation split of 0.3, dropout is 0.4 to avoid the overfitting, and dropout is applied for 3 layers. So here in the table, we can see various hyperparameter settings and the corresponding accuracy and loss results. So in this experiment, deep learning experiment, we obtained the highest accuracy of 93.75%, which is moderately good. And that's why we went ahead to optimize this deep learning experiment with the help of Taguchi method. Now, on this slide also, we can see that there are n number of hyperparameters which are manually set. And by varying those parameters, we try to find out the accuracy and loss results. But it is a cumbersome task because there are various combinations and permutations which we will have for hyperparameters, and we won't know which is the best working one unless we try it out on our own. So for the optimization of number of experiments, we apply the Taguchi method to find the best combination of hyperparameters. Now there are few steps which we carried out under Taguchi method. First, to decide the control factors. As we can see in the table, we have set 6 control factors: training data set, learning rate, batch size, epochs, number of dropout layers, and number of filters in the dense layer. Now, by varying the levels or varying the values of control factors, we can set the levels. First 3 factors have only 2 levels, and next 3 factors have 3 levels defined. So total number of experiments, if we want to experiment with our DL model, deep learning model, then we would be experimenting or implementing 3 raised to 2 into 3 raised to 3 number of experiments, depending on the levels. So first for all the permutation and combination, and that's a lot. So to reduce that, to optimize the number of experiment, we find the orthogonal array. Using the orthogonal array, we can balance out the control factor levels and finding out the best solution with less number of runs or less number of experiments. So using the formula, we get for our task, depending on the control factor levels, we get value of n is 8. However, there are 2 levels and 3 levels defined for various control factors. And so the number of experiments for a balanced orthogonal array must be divisible by 2 and 3. And next higher number than 8 is 12. And so total number of experiments that we run are 12. Here is the orthogonal array where we define the combination of control factors with specific levels. And this is a balanced one, as I've mentioned, divisible by 2 and 3, so we could balance it equally. The performance metrics are signal to noise ratio for larger the better and signal to noise ratio for smaller the better. Obviously, SNR for larger the better will be used for accuracy and the other one for loss. We calculated SNR-L and SNR-S, and the results are here for all 12 experiments which were defined in orthogonal array. Now, for SNR-L and SNR-S, we have different values mentioned here. And now the next analysis is analysis of means, where we find how our experiment is varying in terms of means from the overall mean. So ANOM, that is analysis of means method, is used. In this, the combination of control factors at each OA trial is considered, and we average those signal to noise ratios to find the control factors at that particular level. So the results that we obtain are depicted in the tables. So SNR-L for accuracy. Here we can see column wise for control factor 1, level 1 generates this accuracy. I mean, obviously, not accuracy, SNR-L value. And the ones which have the highest value, which we have highlighted here. So accordingly, From table 1, the best combination of control factor levels are 1, 2, 1, 3, 3, and 3. Similarly, for SNRS, which is a loss value, depicting the loss value, here also we find the values here, the better value, and we again get the best combination 1, 2, 1, 3, 3, 3. Had it been the case that these two combinations differ in any of the control levels, we would have gone ahead and we would have performed ANOVA, that is analysis of variance. However, we are getting the same best combination and we do not need to perform the variance analysis there. And that is why we stick to this as best combination. So this is the best combination that we get. And to validate the result, we run the experiment for control for these particular control factors with these levels. And the accuracy that we obtain is 95.2% with 0.02 loss. So this is higher than the tried combinations on the DL experiment. And so we can say that in less number of experiments, we could obtain the best hyperparameter combination to generate best accuracy and loss results. So this is the validation of the Taguchi method implementation. First, we have deployed the AlexNet-based DL model for FER system, and then optimization using Taguchi technique. Using DL model, the best accuracy that we got is 93.75. But for different hyperparameter combinations, after applying Taguchi method, the accuracy was 95.2%, which was validated as the best parameter combination, which we obtained as a result of Taguchi implementation. So it is found to be efficient, and the future scope obviously is to compare all the hyperparameter tuning methods. Taguchi method with grid search or random search can be carried out as a future scope. So these are the references that I have used, and that's the end of my presentation. Now I'm open for any questions.
Sir, any questions?
Yeah. Dr. Kale, am I audible?
Yes, yes, sir.
So you have used Taguchi method. Now,
Yes.
This method, is there any literature where this method is utilized for the purpose that you are serving, facial expression, or is it applied somewhere else?
No,
Yeah. So
no,
this
sir.
is
It is not used in. It is not used for facial expression recognition. I could find out the related work where it is used in neural networks for CNN and for other deep learning applications, but not specifically for this particular application. Because anyways, this application I find very innovative, and there is no much literature specifically for this application on facial expression recognition using this approach for Indian performing arts specifically. So there was no paper which has the reference for Taguchi implementation on the same.
now when you say Indian performing arts, and somewhere I could hear that you have utilized Japanese expression as a data
Yes,
set.
yes,
So don't you think there would be a mismatch, or I mean,
yes. So actually, the experiment which was performed on AlexNet, that is specifically for the application-specific database, as we can see in the first column. The most of the experiments which were run on the created dataset, I just combined another facial expression dataset just to have the variability. And even though if you use application-specific dataset, the accuracy that I obtained is 91.66%. It was also moderately good, and that's why I went ahead with the implementation of Taguchi method and did not remove the Jeff dataset from the combined dataset.
okay.
So the main
That's
purpose was to see whether the optimized parameter combination works out to be fine or not. That was the main purpose. And so that is why I have done so. And as you are rightly mentioned, that Jeff dataset is quite a mismatch for this application. So actually this paper was to, the main objective was to see the implementation of Taguchi method. For the FER system, using only application-specific dataset, I have other publications on that particular domain.
okay. Thank you.
Yeah.
That's it from my side.
Yeah. Thank you, sir. Thank you, Dimai.
Thank you, ma'am. Now, next, I would like to call Suhas Bhise. Suhas, sir, are you here with us? I repeat, Suhas sir or any of the co-authors. Thalapaka Nikhila ma'am. Is Nikhila ma'am or any of the co-authors present here? All right, Basam sir, can you hear me?
Good morning.
Yes, sir. Can you present your study now?
I will presentation now. Okay.
Yes, sir. Please present your paper on Monte Carlo validated AI framework for log and permeability imputation in carbonate reservoirs.
Okay. Now, screen.
Yes, sir. We see the last slide of your presentation.
Okay. Good morning, everyone, and thank you for joining us today. My name is Bassam Abdulhamid Abu Turab. And this work is collaborations with Wasan Wali and Mus'ab Al-Aziz from College of Engineering, University of Basra. Our presentation is titled Monte Carlo Validated AI Framework for Log and Permeability Imputation in Carbonate Reservoir. In carbonate reservoir, permeability is important features is only for the most important properties for the understanding flow behaviors for the any well in the world. So that in this study we now to solve many problem about missing core operations. On the next slide, we will show where from we can get this data for wireline and for core expensive. In this video, you can see the wireline logging tools being lowered into the well on the around cable. This tool included electrical sensor, acoustic devices, and radioactive detectors, which measure properties such as gamma ray, resistivity, density, neutron porosity. As the tool move along with the wellbore, all these measurements are sent to the real-time for engineering recording the surface with table unit. This result is continuous yet as high resolutions log data curves with depth for all wheels depth, and these are exactly the type of data we use in our study to build and validate the artificial intelligence in framework. This type of operations, wireline logging tools enter to the run-in hole for any wells. After that, record all data properties for the rock, properties for geological. This type of data now for wireline. And the next for core. This core also important features. In our study using permeability features for this properties for rock and geological reservoir. In this video, you can see the coring processes where the special coring assembly cut cylindrical rock sample from the reservoir and bring it to the surface. This core sample are then taken to the laboratory where the measurement key properties such as porosity and especially here in our study permeability features. Permeability of core analysis tell us how easily fluid can flow through the rock, which is directly for the predictions for the well, and it's very important features in the well and the estimation for the predictions based on for any reservoir. As you show in this video, this operations is high costly, high technical complexity. so that this operation not take for any well. For example, if we have field in the world, all the wells in the field have wireline logging, but not all wells have features, core features, because it's high costly, complexity technical. So that we now in this our study using artificial intelligence to impute to evaluations and imputation for missing for this data. As you see, take sample from the core underground wells. After that, take it to the laboratory. This type of data, core data, very, very important data. Now in our study, as you show before some time, the features permeability. Why this research matters? As you know, the missing data in wireline for many cows, for tool manufacturers, borehole time constraint, harsh for the hours, sometimes for the sensor in the well. High hit, the reservoir that working, getting this data, carbon reservoir are geological complexity, high complexity, and difficult to characterize. A critical rock for permeability features, control, reservoir quality, flow behaviors, and productivity. Limited core measurement. Core-based permeability is sparse, costly, and operations challenge. Incompleted logging, well logs are often incompleting or partially missing, especially in all older wells. Problem on research gap. Current practice logging and permeability are often modeled separately. Random data split cause depth leakage between training and testing. Predictions are given as a single value with no uncertainty. Permeability is a trait as if where complexity unknown. The reality core permeability values do exist, but only specific depths are sparse. This make a big problem in our reservoir in the world. Research gap here need for a unified depth-aware artificial intelligence framework that can be completed missing log and field core-based permeability values to provide uncertainty estimates that engineers can be used in the field. Goal and key contributions. Goal, develop and validate field-ready artificial intelligence framework for the joint log and permeability imputations in carbon reservoir. From field-ready AI, complete missing log and infill core permeability, depth-aware Monte Carlo block depth leakage and calibrate uncertainty. Integrated RQI flow zone indicator. This features engineering from our data, reservoir quality index, and flow zone indicator and species for labels, delivers geologically consistent permeability features trend, reproducible workflow, easily transferables across carbonate wells and the field. Data and geological context, as you before sometimes show, there's two type here data from wireline and from core. Single core carbonate wells. Here our study on the one wells field X, we couldn't show the name of the field for security with the 819 carbonate core sample. Multi-log input suite here in our wireline record data we get from this study, gamma ray, from sensor gamma ray, from sensor induction, SP, spontaneous potential, bulk density. These features important from wireline We have missing in gamma ray and missing data in induction, so that we're using artificial intelligence to imputation this missing. Predictive target core derived permeability features K profile along depth. Geological contents, multiple lithophases with strong vertical variable typical for complex carbonate reservoir. Permeability data set strategy missing data completions. Here's our will have missing in wireline and missing in core data. Observed permeability core derived value available at the specific depth only. The big problem sometimes occur in the core data for after record, not record for all depth survey, sometimes missing for interval depth. Model objective, input missing permeability features value between and around core. After solutions, we can impute this value. Data learning the relationship between logs. We using here in feature engineering after adding feature and new features from our feature wireline and RQI flow zone indicator and phase and K features permeability. Verifications, synthetics data massing, height control. And this field, we using data but hidden some features and training others. After that imputation, this hidden features and compare with original, we get high resolutions to ensure and apply in our reservoir. Pre-processing step outlier clipping using IQR, robust scaling median IQR for stable training.
Excuse me, sir.
Yeah.
Due to time constraint, I would request you to please conclude your presentation within the next 2 minutes.
Yeah. Our artificial intelligence architecture stacking ensemble using Catabos, DAA, dynamic autoencoders, transformer stacking ensemble. As you show in this image, data input, reprocessing, geological descriptions for RQI, flow zone indicator, base model, Catabos, autoencoder transformer, using stacking to get more accurate predictions. After that, Monte Carlo to prevent leakage. As you in this after we're getting the result for the imputation using Monte Carlo 30 block dependent Monte Carlo. Divide the well into the depth block. After that, perform 30 Monte Carlo runs with different terrain and test block assignment. Generate ensemble of the depth-wise predictions for gamma ray inductions and permeability features. Obtain a prediction interval, mean and standard deviations, and avoid depth leakage. This important for using this feature, these tools. As you know, our result here for first features that have missing for gamma ray, we're getting high performance by Catabos 0.99 and the mean absolute error 0.01. Also for the induction features, we're getting 0.99. As you know, this original for gamma ray. After making this Catabos, we get similar for behaviors for our original. Also for induction sensor, this is original and getting for Catabos similar and high accuracy. And for the third features important here permeability, this original K core permeability, we Catabos getting with high R square 0.98. Uncertainty using before some time show uncertainty quantifications and MC30 output to prevent leakage in our data. A statistical calibration coverage close to nominal level slightly conservation model is honest about confidence. Value for decisions support risk aware choosing in testing and combinations and development planning. From back to black box to prevent the black box in our machine learning using geological consists to make respect to petrophysics reservoir integration, new features, RQI and flow zone indicator, porosity, and facies information. Physical accuracy, verify K permeability trend, and respect facies and shell sand transition. Reliable tools combines strong numeral performance with realistic geological behavior. Real-time, real-world field benefit in this, our solutions handle incompleted log and spar core data through AI-driven imputation completes the input data using for the permeability predictions and facies classification to increase the accuracy, maximize value for existing fragment measurement instead of of acquiring new data. Reducing the very important in this solutions, reducing cost, etc. logging and coring operation enable fast evidence-based development decisions with prediction. Limitation in our this study, we're using one well pairs, and in the futures maybe use multi wells, maybe using multi features for seismic, for other features to increase generalization for all the world in different field and different field. Thank you. If you have any question.
Sir, any questions?
No questions from my side.
All right. Thank you, sir, for your presentation.
You are welcome. Thank you so much for your time.
I would like to give one last call to a few presenters who weren't present. Seshu Kumar Chegu, Ator Rahman, Suhas Bise, and Thalapaka Nikhila. If any of them or their co-authors are present, please let us know. I would like to wait for 2 minutes before proceeding with the concluding remark. I repeat, Seshu Kumar Chegu, Ator Rahman, Suhas Bise, or Thalapaka Nikhila. Excuse me, Vijayalakshmi ma'am. Vijayalakshmi ma'am, am I audible to you?
Ma'am? Ma'am?
Yes, ma'am. Vijayalakshmi ma'am, can you please confirm if you were a part of 3B session? I believe there was some misunderstanding. Let us wait for last 2 minutes before we proceed with the conclusion.
Power to the individuals and the depends on
Excuse me, Vijayalakshmi ma'am. Please respond if you can hear me. Ma'am. All right, we'll begin with the concluding remark now. I sincerely thank our authors for their excellent presentations and contribution in this session, and all the participants for being a part of this international conference. On behalf of the whole team, thank you for the support during this version of conference. We will be happy to have you in the next version of 2026. All the presenters would be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of MCT4SD 2025. I would also like to thank our session chair, Dr. Kaushal Shah, for chairing our session. Thank you for a valuable presence, sir. I would request you to share any few words you may have for the team, sharing a token of appreciation on the behalf.
Yeah, thank you very much for having me. And thank you to all the authors for sticking to time. I guess apart from one, we didn't have to warn anyone to, complete quickly. So that's a good thing. And yeah, somewhere in future, if we can meet physically, I would be happy to help as a physical session chair in one of the future conferences. Thank you.
Thank you so much, sir. And with this, we conclude our session. I kindly request everyone to please turn on their camera for a quick snapshot.
Uh, One more question. Yes.
Yes, sir.
Uh, this is the section. I mean, I go into this room earlier, right? Because I saw the website show is 4:30. I think I go here earlier. It's right, or just wait. My mean is we will continue or just leave out now.
Sir, do you mean you were about to present in session 3B, or there was some another session that you were a part of?
No. I mean, I'm in the section 4B, B4. So I think I'm earlier to come to this room, right? I
Okay,
just
okay,
confirm.
okay. No worries, sir. You can enjoy the other presentations till then.
Okay.
Yes, thank you, sir. We will join you again later in the next session. Thank you.
Thank you.
Thank you, everyone. You may leave the meet now.